Welcome to AK App Logics. In the previous class we have discussed about the LED, how to interface the LED, and we have blinked the LED, and also we also discussed about the serial monitor and all these things. If you didn't watch those videos, please watch those videos. So in this today's class we are going to discuss about how to interface the push button to the Arduino. For that, let's make connections. To interface any particular thing we have to discuss with the connections, and also I will discuss some points about the push button. So for that I have taken the uh, breadboard, and I have taken the push button. So let me discuss some points about this push button. So this push button is basically have contains uh, one button, that is this particular thing. In the middle black one is the one button. So the connection, how does the connection will be there? The thing is, how does the connection will be there means, so this top two are connected like this top two are gets connected, okay, and this bottom two are gets connected. We can use this particular thing, we can use this particular thing. So we can connect one end of uh, any pin to this and another end to this pin, and the connection is established this between this particular two pins internally in the push button. Whereas similarly, the connection is established between these two pins internally in the push button. When you push the button, when they push the button, the connection will be happen between these two pins and these two pins. And also when you releases the push button, the connection will automatically disconnect. Push button in the sense means, when you push, the connection will be happen. When you releases your finger from it, then the connection will automatically disconnected, and it will again be in the open state or the off state. Okay, so this particular push button configuration will be in the two types. That is based on how we gonna connect. Okay, how we gonna connect uh, this push button to the Arduino, or what is the off state voltage that we are going to receive. Okay, based on this, and how we going to connect resistance to it, all this stuff, we will have an two different types. Those are push button in active low with pull up resistor, push button in active low with pull up resistor, and push button in active high with pull up resistor. Today let us discuss about the push button in active low with pull up resistor. What does that mean? So let me take these two particular pins. Okay, so let me connect this particular thing. You can also connect this one as well, because it's a bidirectional. The switch is always the bilateral. Okay, so it means you connect any pin to anything. This pin to anything, you can achieve the same. Okay, the resistance offered by the two pins will be same. Sorry, in the same direction of two pins will be same. So the thing is, let's use these two pins. Okay, let me show you. uh, just a second. So I'm going to discuss about the push button in active low with pull up resistor. Let us discuss pull push button in active high with pull down resistor in the next case. Okay, for that I have taken resistance. Okay, how much this value is? This value should be I'm going to keep it as 330 ohms. Okay, there is no particular reason to keep it, so I'm just keeping. In the previous class we have kept 330 ohms, right? So, and its name is pull up resistor. Why it is called as pull up resistor, I will discuss. And also we have to know the breadboard connections. So the thing is, this A, B, C, D, E are columns wise. There will be same connection. Okay, shorted, column wise shorted. Whereas F, G, H, I, J are columnly shorted, and this plus and minus are horizontally shorted. Okay, minus are horizontally shorted. A, B, C, D, E are separately shorted, and whereas F, G, H, I, J are separately shorted. So that what I have done is, I have kept these two pins which have an internal connection between them, the push button to A, and you have to see this column number. This will be 30 column number, that will be 25. The next one will be 26, and the next one will be 27. And have connected this particular push button upper pins to A25 and A26. Okay, like this you have to see the connection, whereas the bottom is to F25 to F27. So there is no connection between A and F, right? They are separate blocks, right? They are from the separate blocks. If they have the connections between them, then the both these particular internal two different short connections, or the all these four pins will be shorted. Okay, but it's not our requirement, right? So I have connected like this. And also see, I have connected a resistance of 330 ohms, which is a pull-off resistor. Why it is called as pull-off resistor, I will tell later. So connected it to A23 and A23 and A17, you can see over here. Okay, let me, okay, A17. Okay, like this you have to make connections. So you shouldn't make a vertically. Why? Because if you make the vertically, this particular pin and this particular pin are in the same shorted line, so the resistance will be shorted, right? So you have to make sure to make the connections on the breadboard while you are going to perform this particular uh, mini project on the breadboard. So let's discuss next thing. So here it is. Till now it was okay. From now on it will decide whether it is a pull-up resistor or it is a pull-down resistor based on our connections. So let us see. So let me, yeah, I have connected one end of resistor to the one end of button, and I have connected other end of resistor to the 5 volt supply. Remember this point, other end of resistor to the 5 volt supply. Okay, so next I have connected other end of button to the ground. So, and I have taken the output from the resistance, and in between resistance and push button to the, I have given to the pin number 9. Okay, with this the connections are made. So by this what happens is, when we given the power to the this is the particular code. Okay, I will explain this particular code again. Okay, let me, when we uh, doesn't press any button, this doesn't press the push button, so by default it will get shows the, it gives the 5 volts. Okay, it will gives the 5 volts to this particular pin 9. Okay, pin 9. Okay, it means, what does it mean? Means it's a pull-up resistor. Means when it is ideal or the off state, the output we are getting from this particular ninth pin is a high, right? It means the resistance is pulling up the voltage. Okay, the resistance is pulling up the voltage when it is in the off state. Okay, that's why this particular resistance is called as pull up resistor. Okay, when you press this particular button, then what happens is when you press this particular button, then what happens is the connection in the internal pins will be happen so that the current flows continuously from 5 volts to ground, and the closed path will be formed, right? Right, closed path will be formed. Then the output that we have taken from this point to the ninth pin will be 0. Okay, because it's an open circuit, like it will treat like a open circuit, and we will get the output 0. uh, in the practical case we won't get the output 0, but less than the 5 volts, and also it may get from 0 to it may get from 0 to some 1 to 1.5 volts. Okay, so the thing is, why it is called as active low and why it is called as this particular resistor called as pull up resistor means, why it is called active low means, when you push this particular button, then you are getting the output 0. It means low. When you push the button or the on the button, you are getting the output low, so that it is called as active low condition or the active low configuration. Whereas why this particular resistor is called as pull up resistor means, when it is in the off state we are getting the 5 volt supply or the high, so it means the resistor is going to treated as the pull up resistor. Why? Because it is pulling up the voltage value 5 volts. Yeah, so I hope you guys got why it is called as pull up resistor and why it is condition is called as active low. So yeah, so pull up resistor, why? Because it's pull up the value from 0 to 5 volts when it is in the off state. What is in the off state? Push button in the off state or the open state. Whereas why it is called as active low, when it is the push button is in the active, that is the on state, we get the output 0 volts at the low, so that it is called as active low. So let us, this is the connections, you can make these connections by your own. So let us discuss about the programming code. Let me erase this particular code and explain step by step for you guys. This is my practice work. One video contains this much of hard work, so I forgot to erase this particular thing. So let me erase this and tell you. Yeah, so let me discuss code one by one. So first what we have to do, based on our previous knowledge, we have to uh, take this pin number 9, which is the push button input pin. Okay, push button is an input device, right? So we have to take this particular 9th pin as an input. For that I am going to declare the int push button, okay, equal to 9. Okay, and remember this point, it's very important. When you are going to write the uh, write to the any pin, you shouldn't declare any variable. When you read from the outside pole to the pin, you have to declare one pin, extra pin, to know the state of that particular pin, so that I am declaring button state pin, that button state variable. So why this particular pin means, so when you read, we are reading from the 9th pin, right? We are reading from the push button to 9th pin. So what we are going to read, whether it is high or low, based on those we have to perform some task. Okay, it's our requirement, right? While writing, we will know what we are going to write to the outside, whether it may be high or low. We will specify that particular thing. the code itself. So while reading, what we are getting, we don't know, right? We don't know whether it is getting high or low. So for that we have to initialize another variable, so that I have taken it as button state. So next we have to declare the whether it is an input or output uh, pin for the ninth pin. For that pin mode, I'm declaring pin mode push button input, and next I'm going to initialize the serial dot begin, which is the serial monitor, and I have given 9600 baud rate, which I have discussed in the previous class. If you don't watch this, please watch this particular thing. And next I'm going to use digital read. For suppose if you gonna do like this, digital read of push button, from which pin we are going to read? From the ninth pin itself. For that I have given inside push button, digital read is used to read from the external world to the Arduino, into the Arduino. For that I have given. So what we are going to read, whether it is high or low, for that we have to declare extra variable, as I previously told you, right? That particular variable is button state. For that what we are going to do is button state equal to digital read of push button. By this button state, what does it contain? The push button, what does the push button pin, that is ninth pin, is receiving? Okay, this particular thing will be stayed in the button state. So by using this button state, and by using if else condition, why if else, button state can able to store only two values, that is high or low, right? By using this button state, by using if else, we can use some statements to the printed over the serial monitor. That's the main task. So see, if button state is low, it means if we are receiving the low from the ninth pin, when will we receive the low from the ninth pin? Whenever the push button is pressed. Why? Because it's an active low, right? It's an active low. Whenever it's an active low, when we on the push button, then we receive the 0 volts or the low voltage to the ninth pin. So whenever this particular condition happens, what I'm going to say is serial dot print push button is pressed and value is equal to, what does the particular value equal to? It obviously it will be equal to the button state, right? So this particular statement will be printed, and what does this value is equal to means, it will be obviously equal to the button state. So that I have to print that particular thing as well. So for that I have used print ln. After this particular statement, there will be, the cursor will be moved to the next line. So I have printing the button state. If this is true, then it should be display uh, whenever, if button state equal to low, push button is pressed and value is equal to button state, right? Yeah. So next, else, similarly push button is not pressed and value is equal to, okay. Yeah, and I have going to specify some delay, you can see over here, and let's run the code. So you can see I'm not pressing any push button. I'm not going to press any push button. So it's showing push button is not pressed and value is equal to 1. What is 1 mean? The pin 9 is receiving 5 volts from the push, this particular point, from the push button. Why it is so? Because of these connections. So it means this resistance become pull up resistor only, right? What I have told, when we don't press this push button, I'm not pressing, you can see continuously we are getting push button is not pressed and value is equal to 1. So that the pull up, it will become, the resistance will be become pull up resistor. Why? Because when we doesn't press the push button, the output is getting high. even though we are not pressing the push button. So that this particular uh, resistor will be treated as pull up resistor. It means it is pulling up the voltage value from 0 to 5 volts, or you may treat it as it is pulling up the resistor, it is pulling up the voltage to the maximum voltage, that is 1, that is 5 volts, whereas in case of binary it is 1. Okay, so when I going to press this, uh, press and placed my finger over there only, and when I remove, again we are going to get push button is not pressed and value is equal to 1. When I press and leave my finger over to the push button, you can see push button is pressed and value is equal to 0. Okay, I'm going to press only. Now when I leave, so you can see the change. Let me zoom and show you. So see, I pressed and leave, I pressed and leave, I pressed, leave. So when I pressed and hold, it shows push button is pressed and value is equal to 0. What does the active low mean? When I pressed the push button, we will get the output voltage to 0, that is low. It means whenever the push button is active or on,